Hello and welcome to another science one-on-one lesson with me and Mr. N. So now and we will learn about using a periodic table and what they are. What's the periodic table and elements and all the chemistry concepts. Let's read it now, shall we?
Periodic table of elements. Definition. Elements are pure substance that consists of a single type of particle or atom. Over time, scientists have found a way to organize the element according to their physical and chemical properties, known as the periodic table of elements. One example of an element is oxygen. Oxygen is a gas at room temperature and it is found in the air around us. On the periodic table, it is identified by the letter O. Do you know any other element and their symbol? So I would say so I would say
Hydrogen, oxygen, chlorine, carbon, nitrogen, something like that.
carbon and nitrogen. Following the periodic table. Now it's time to explore the interactive periodic table and find out more information. Take a look at the following resource and answer the question that follow. So, exploring the periodic table. One of the most distinctive feature of the periodic table is that it's grouped element as metal,
metalloids and nonmetals.
You will examine the feature of each group, this periodic table. Show the metal in blue, the metalloid in green, and non-metal in red. Metal. Metal are by far the biggest group of elements. You are likely familiar with metal. They are generally hard, malleable, bendable, conductive, and
Malleable. Like for example, you can shape it in any way you want. You can bend it in any way you want. Ductile, it means you can stretch it into wires. Like for example, a piece of metal, you can just squeeze it, stretch it, so it become a wire or threads of metals, and it's shiny, like it reflects light, like a shining metal.
Yeah. And shiny.
Exactly.
Almost all metal are solid at room temperature, and they have very high melting point.
The one
The
exception is
one
mercury.
is mercury, Hg, which exists as a liquid at room temperature. As they are malleable and ductile, metal can be pulled and shaped into wires and other useful objects. Most metals are also good conductor of electricity and heat. The combination of being good conductor and being able to shape into wire easily make metal very useful in industry and for carrying electricity. Commonly used metal include copper, aluminium, lead, and iron.
Mm-hmm.
Iron is the Earth's most abundant element. If you consider the whole Earth, including its crust and air
Mm-hmm.
surrounding it reacts with other elements, such as carbon, to make useful material such as steel. Though many metals are abundant, some are very rare. Metals such as gold, Au, silver, Ag, and platinum, Bt, are rare. These metals look very attractive and can be made into beautiful jewelry, as they are rare and desirable.
Mm-hmm.
They are known as precious metal.
Precious
These,
metal.
yeah,
Of course, they are precious because, like gold, silver, and um, what's it called, platinum.
yeah,
It's not rare in nature. It's not rare, but actually, humans we consider them very expensive. You know, we actually pays a lot of money to have them. So basically, they are expensive in human society. It's not because these metals are. It's not because these metals are rare. Okay, it's not rare. Basically, it's just expensive and it's precious to human. That's why we call it precious metal. It's not rare, okay?
yeah, I understand. These
Okay.
metals do not react with any others. For thousands of years, people have valued these metals, especially gold, turning them into work of art, coin, religious object.
You know, basically the color gold, yellow gold, is actually beautiful. So that's why everyone loves it. A lot of people loves it actually, especially the royal family. So that's why it's also called precious metal because the royal, precious, use it. Silver also,
Mm,
silver, silvery. It looks beautiful. Of course, it looks beautiful. And silverwares like silver forks, silver cutlery in the kitchen or in the dining room. Those things are expensive and it lasts very long. So that's why we human use it.
So it doesn't like rust over time,
No,
right?
it doesn't rust because it doesn't react. So it just remain as shiny and beautiful as it is. Of course,
Yeah.
dust will settle. Dust will be settling on it, but you can just wash it with water, no problem.
Okay. Non-metal are quite vary in their appearance and can exist as solid, liquid, or gas at room temperature. Familiar examples of non-metal include gas such as nitrogen N and hydrogen H, and solids such as carbon and
Mm-hmm.
sulfur S. Non-metal are brittle, poor conductor of heat and electricity, and have lower melting point than metal. They are generally dull in appearance. Let's take a look at some example of non-metal. Carbon, C. A solid non-metal. Carbon react with many other elements in complex way to produce a great variety of material. Fossil fuels such as oil, coal, and gas are built mostly from carbon. A diamond is a form of pure carbon that is extremely valuable in jewelry.
Basically, right now we can create diamonds artificially, so I don't think they are that precious anymore. I mean, America compared to
Uh,
gold, other things, but it used to be very, very precious, because it's beautiful, because it looks beautiful, extremely beautiful. They used to say that diamond is the woman's best friend, you know,
Yeah,
for a
I
reason, of
understand.
course.
Carbon is also found in simple objects like the graphite in your pencil. Most importantly, carbon is the basic biological chemical that makes up living things, including you. As you will learn, much of chemistry and biology involves studying how carbon chemicals are made and how they work. Oxygen. Oh, a critically important
Yeah,
non-metal.
critically, I
Normally,
think, critically
yeah,
important.
a critically important non-metal. Normally in the form of a gas, oxygen combined with other elements to make a variety of important chemicals. The most important one is water, which is a combination of two non-metal gases, hydrogen and oxygen. Oxygen also forms a gas called ozone, which naturally formed high in the atmosphere and protect the Earth from the harmful radiation coming from the sun. It blocks the intense ultraviolet rays, which can cause skin cancer.
Hmm.
Metalloid are a group
Metalloids.
of
Uh-huh.
small oh, metalloid are a small group of elements that share some of the
Properties
properties
of
of metal
metals.
and some of the properties of non-metal, like the most metal. Metalloid are solid at room temperature. Many also have metallic luster, like non-metal. Metalloid break easily,
And poor
are poor
conductors.
conductor, and are not very malleable.
So basically, metalloids are in the middle between non-metal and metal. So you know they're in the middle. So basically, they're not exactly metal, but they are not exactly non-metal either. They're in the middle.
Yeah, so it's
So
like both and both, but it
sorry.
doesn't.
Yeah, it's share like both kind of properties, but it's not exactly metal, not exactly non-metal either. Just in the middle. For example, if you go up there, you can see. Just scroll up a little bit, you can see like group four. I mean, let's look at the one in green. You can see that B,
Yeah,
boron, silicon, germanium, arsenium, strontium, or thallium, and astatine. I think,
acetylene.
yeah, the name just so small. Anyway, those greens one are basically what they call metalloids. So
Yeah,
they behave just like non-metal, and they also behave like metal too.
common metalloid is a silicon. It is found in electronic devices such as cell phone and computer.
Hmm.
It is also the main element in sand. It is pure form. Silicon is a shiny solid like a metal with
Hmm.
a high melting point. Although it does conduct some electricity, it is not as good as a conductor as a metal. So it is called a semiconductor. Its high melting point and semiconductor properties make it the ideal material for circuit chips that run all modern electronic technology. So like in our computers, like there's like Metalloid. Exploring exploring element on the periodic table. Copy the following table into your notebook and use in the interactive periodic table, or other research. Fill in the blank once you complete your table. Check your answer against the suggested answer provided. Uh, So there's like these.
Yes, so you can. It's better to learn. I think it's better to learn the first 20 elements. I mean, learn the names of them and learn the numbers, because basically you will need them later in your calculations of chemistry. So it's better to just remember the names, remember where they are. The first 20 elements. That's what my teacher always told me in the past, and I think it's very practical too.
Yeah. So there's hydrogen. Helium. Lithium. Beryllium.
Beryllium, boron. Yes. Wait, weird. Okay, beryllium. Okay, so basically, what you need to know basically now, it's so most of the time they follow this pattern. You know about their atomic number and atomic mass, right? Do you?
Yeah.
Okay, atomic mass basically include all the thing inside of atom, like the protons and the neutron, right?
Yeah.
But since the outside of the atom, the electrons, they should be the number of electrons should be equal to the number of proton. I mean, in neutral atoms, proton equal to electron, right?
Yeah.
So
I think.
most of the time, the atomic mass will be almost like double of the atomic number, right? Like for example, you have you have hydrogen 1 1, you have helium 4 2. Okay, hydrogen 1 1. It's like helium 4 2. You have lithium 6 3. Know what I'm talking about?
A bit.
And beryllium is like 9 4, and so on. So basically, it's just double, nearly double of the. It's like the atomic mass will be nearly double of the atomic number. So based on that trend, you can just learn about these numbers easier. You can guess. Beryllium 9 4. 9 4. Boron is like I think 10 5. About 11. 11 5, okay? 11 5.
Yeah.
Carbon is like 12 6.
Carbon.
Yeah, 12 and then 6. 12 6. Nitrogen is like 14 7. Now it's exactly like, 2 times more. 14.7. Oxygen is like 16.8.
16A.
Six, nearly 16. 16.8.
Yeah.
Fluorine is like, I think 18.9. No, it's actually nearly 19.9, actually. 19.9.
Yeah. 19.
Neon like
Neon.
2010. And so on, Sodium, it's like 23.11.
Potassium. 39. And calcium. So beryllium, boron, carbon, nitrogen.
Just right there, I think it's better. Yeah. Because sooner or later you will have to do exercise with all of these numbers anyway. So it's good to remember.
Oxygen. I'm just writing down some of the first one.
Good idea.
Urea. Sodium. Magnesium. Aluminium. Silicon. Forest.
Okay, just learn all the way into calcium 40-20.
Yeah. Okay. And I'm done.
Mm-hmm.
So, go there.
Modern theory. Or just let's read about modern theory, shall we? Hello, are you still there?
Yeah, I'm still here. I'm still here.
Okay, just read about modern theory, can you? The 5 main points. Okay, so basically around the atoms, there are different kind of models in the past, and so a lot of models have been proposed. So this is a modern theory. So it is right now. We're using it now.
Yeah. All elements are made up of small particles called atoms. Atoms are mostly empty space with negatively charged electron moving around dense positive nucleus. Atoms of the given element share physical and chemical properties. Atom cannot be created or destroyed in chemical reaction, though through the rearrangement of electrons, atoms of different elements can combine to form chemical compounds. So these are like from the video. Small orbit around the nucleus has a negative charge. It's electron. Has a positive charge. It
The
is
nucleus of
in
an
the
atom, of
nucleus.
the atom.
It's a proton and has no charge, neutral, and it's in the nucleus atom, neutron. So doing that. Let's. So this is like building an atom. So there's like so
These are several models you can choose from.
yeah, proton, neutron. Lithium, helium, beryllium. So
There's also a counting of all the things on top. You can see proton, neutron, electrons, they counted for you.
yeah. So it's like
Okay, let's just play with this one for a while. Let's just play with this one for a while and you can see what I mean. Okay. And look at the net charge. Okay, now it's equal. It's equal when the electron and neutron and protons, when the electron and protons are the same, it's equal in net charge.
So like when more are like added, they double. They just transfer like to a new.
Exactly. Exactly.
Nitrogen. So it's like from helium to from hydrogen, helium, lithium, beryllium, boron, something like that. Keep going.
Most of the time, the proton and neutron will be the same. I mean, or not almost the same number. Okay, something to keep in mind here. If you change the number of electrons outside, the name of the atom will remain the same, but it becomes a negative or a positive ion only, okay? Try it, you can see. If you just manipulate the electrons alone, you can see that it changes the net charge, isn't it?
Yeah.
But the same, the ion basically is the oxygen, right?
Yeah.
So when you manipulate or when you change the outer shells, which is electrons, the nature of the atom is still the same. It's still the same atom, but it just like, you know, it become ions, positive or negative ions only. However, if you touch it or if you manipulate the number of protons or neutrons, it becomes different element, right? Try it.
I'm trying.
So it all be about the protons. So if you remove the protons, then the element will become something else. So remember, proton, if you remove the protons or include the protons, it become different elements. But if you do thing with the neutrons, it doesn't really matter, right?
Oh, so it's like protons like the positive and the neutrons like the negative.
Nothing, like nothing, like flat.
Yeah.
But the protons are actually the one who determine what kind of element it is. It's what determine like the atomic number, you know, the proton atomic number. Electrons, well, it's just outside. It doesn't affect like what kind of element it is. But if you manipulate the electron outside, the element will become ions, positive or negative ions only. You understand what I mean, right?
Yeah.
Okay, let's just write it down. These are like ways to manipulate proton, electron, and neutrons. Want me to write it for you?
I'm writing it down in my notebook.
Okay, sure.
I'm done.
Mm-hmm.
Let's go back to the activity.
Oh,
Let me just share screen.
share screen again?
Yeah.
Okay, I just wrote for you like 3 things on the chat.
Oh yeah. Oh. Yeah, let me just write a bit more down.
Maybe I should use the oil, essential oil. Okay, now we're doing experiments with elements.
Yeah, we already did that.
Alright.
Safety tip. Using chemical at home or in the lab, it is important to understand the hazards that are associated with them so that they can be used safely.
Safely.
Read labels prior to the use and take
appropriate
appropriate.
precautions. You know, chemicals are dangerous. A lot of them are very dangerous and harmful to our health. So people need to be extremely careful when they go to the lab.
It costs like a virus.
Say again?
COVID-19. Like the chemical could like cause COVID-19 again all over.
Chemicals? No, actually, not COVID-19. It's just harmful.
Or just any virus, or just a new virus.
Omicron? You're talking about Omicron, do you? Like a variant, a new variant of COVID-19.
Yeah.
It just keep disgustingly mutate and things.
To make sure that everyone understands the safety requirement of different substances, Canadian use a common information system called the Workplace Hazardous
Hazardous material
Material
information.
Information System, or YHMIS.
Hmm.
The system includes the use of suspicious label for identifying hazardous substance. Some substances have more than one warning
Warning
symbol.
symbol. Warning. Hazardous material detected. It's like a hazardous material.
Yeah.
Oh. Share screen again, please?
Yep. So it's like D2B. Take some time to explore the WHMIS pictogram and the expand its description of classes and categories associated with the symbol. The Canadian Centre for Occupation Health and Safety is a central reference point for information about health and safety legislation and practice in Canada. Feel free to explore the website further if you are looking for more information. It's just like the following pictogram will be associated with hazard class and categories. Select one to learn more.
Hmm. Flame for fire hazard. A lot of organic. We have inorganic and organic substances. So organic substances mean like they come from like living things. So
Yeah.
a lot of like most organic substances are flammable, so they will burn if you're not careful. They catch fire easily. Okay, let's just read it first.
There are many different types of chemical, all which have the potential to catch fire.
Mm-hmm.
These products have the ability to ignite,
Ignite. Mhm.
which is catch fire easily, and the main hazard are fire or
It
explosion.
explodes. It can sometimes explode, yeah.
Yeah. It's like when you're in a lab when you're like doing an experiment wrong, it's just like
Mm-hmm.
goes up the flame. These products may catch fire very quickly, spontaneously, if exposed to air. These products may catch fire if exposed to air only after a long period of time or when in large amount. These products react with water to release flammable gases. In some cases, the flammable gas may ignite very quickly. These products may cause a fire or explosion if heated. These products may react on their own to cause
A
fire or
fire
explosion,
explosion.
or may cause a fire explosion if heated.
If heated.
Second one, flame over circle for oxidizing hazard. Oxidizers are chemicals that can cause fire to occur. Even without oxygen present, they
Present.
make a
Even without oxygen present. Present is an
present.
adjective. It's an adjective.
Oh, sorry,
It's
present.
without oxygen present. They make already existing fires hotter and burn faster.
These
Like
products
oxidizer, for
may
example, concentrated acid, for example, concentrated acids. They oxidizes very well, and basically they just cause fire, even without like oxygen present there. So they are dangerous.
these products may cause or intensify fire or cause a carbon
A fire or
fire or
explosion.
explosion.
Oh, gas cylinder.
A cylinder.
Like for example, if you have like an oxygen tank, for example, or a nitrogen tank. It's a huge cylinder and heavy, huge and heavy in the lab. Gases and the pressure. Have you ever seen like gas tank that people often buy and then carry on the streets?
Yeah, I saw some in the highway.
Of course. So these are gas cylinder too. Of course, they are very dangerous, but people still do that on the streets. Probably no one has died because of that yet. So maybe.
With someone might.
But if this gas tank explode, oh my god, it's gonna be a huge fire, and then a lot of people may die.
Yeah. This class includes compressors, gas, liquefied gases, dissolved gases, and liquefied gases. Compressed gas, liquefied gases, and dissolved gas are hazardous because of the high pressure inside the cylinder or container. The cylinder or container may explode if heated.
Refrigerated liquefied gases
Are very cold and can cause serve cold.
Cryogenic. Cryo means ice. Cryo means ice. Genic means to create. Generate, generate.
Regenerate.
Generate, yeah, generate means to make something new. Cryo means ice. So to make ice, so called severe cold, burn or injury. You can have burns when it's like very cold too. Try touching a piece of ice, and you feel like your hands can become numb, very numb, and you cannot feel anything, right?
Yeah, it's like
but sometimes the ice stick to your fingers too, and it's difficult to get to remove it, right?
Yeah.
These kind of severe cold are worse than that. You can get burn, like I call ice cold burns, severe cold burns or injury. Okay, corrosion. This is the most. I think this is one of the most common. You have acid and bases, which can eat through your skin or your eye very, very easily.
It dissolve through like metal.
You know what household products are corrosive?
Not sure.
Bleach.
Bleach.
Have you ever seen bleach? Bleach are used to clean, to wash clothes, like to remove like stains, color stains, and to clean the bathrooms and kitchens. But these are corrosive, so you must wear gloves, when you work with them. And also, bleach are dangerous when you inhale it in. It can cause headache and convulsion, like if you inhale too much. But of course, headache. It will cause headache.
These products may be corrosive, chemically damage or destroy to metal. Will cause syrup, skin burn, i.e. corrosion, and product that cause skin irritation. Can cause serious eye damage.
Irritation.
And eye irritation. So
especially like gases, gases in the lab. Because in your eye, of course, there are water inside of your eyes. So it might dissolve the gases and cause like acid, small acids build up in your eyes, and it cause like eye irritation.
Your eyes are like exposed to the gas.
Your nose too. Your nose, actually, there are water inside your nose and your mouth. So if you inhale these gases, they can dissolve inside of your nose and mouth. Yeah, and then it can burn your nose.
Oof, that sounds rough.
Of course, that's why when you work with chemical, you have to be very careful. Like, for example, with chemicals that produce gases, you have to have well-ventilated rooms, like fans and open windows and things like that,
Yeah.
Of course, these things are very rough. Okay, skull and crossbone, it means deathly, you know.
Yeah, or toxicity with short
Fatal,
exposure.
deadly, toxic, harmful, even hell, follow skin contact if swallowed.
I saw that sign sometime.
Of course you do. There are things with that sign. For example, you know, like rat poison, right? Poison to kill rats, right?
Yeah.
People use poison, rat poison, to kill the rats that infested their homes, you know. But these things are toxic, very toxic. Some children, they might accidentally ingest it because they thought it was candies, you know, and they died. I mean, there have been cases like in Vietnam, the skull and crossbone, you know, because a lot of like these kind of toxic thing, they look like candies too.
Okay. These products are fatal, toxic, or
Fatal,
harmful if
deadly,
inhaled.
fatal or deadly is the same thing.
Yeah. Following skin contact or if swallowed.
Acute
Acute.
toxicity, acute means like short term, you know, like
Like long.
immediately after you get in contact with these things. It's short term, so acute. Acute
Yeah.
toxicity means like short term after you got it, you get intoxicated. Your body become intoxicated.
Acute toxicity
Very short time after exposure, you get it.
refers to effect occurring following skin contact
Or
or
ingestion exposure.
ingestion exposure to a single dose or multiple dose given within 24 hours, or an
Inhalation
inhalation.
exposure of 4 hours. That's why I say do not inhale them for too long. It's like bleach can be dangerous too if you inhale them for too long. It's not only headache, you know. It's not only cause headache, you know. Can cause like hallucination, so you will start seeing things, and you might just, you know, cough and fall down if you inhale them too much. So basically, that's why cleaning ladies, cleaning people, they are exposed to these chemicals all the time, you know, bleach
Yeah.
and, you know, these kind of things.
Acute toxicity could result from exposure to the product itself, or to a product that, upon
Product is a
contact,
product because it's
yeah,
a noun. When it's a noun, it's pronounced like product, not product.
product,
You know, it's a product to a product that upon contact with water. Because contact here is a noun too. So upon contact with water, not contact. Okay. Upon contact with water, releases a gaseous substance.
that
Or
is
substance. Oh,
able
it can
to
release
bond to.
gases. It can release toxic gases and cause acute toxicity.
Ooh,
One thing to keep in mind is to never mix vinegar with bleach, you know. Vinegar and bleach. Even though they are both very good with cleaning, when you mix them, they produce chlorine gas, Cl2. And chlorine gas is basically dangerous to human to inhale in. They can cause severe burns inside of your nose and your lung. Very, very painful. You know?
yeah.
Chlorine gas Cl2 actually was used during World War One as a
Really?
weapon, as a chemical weapon to kill the enemy. So basically, these are created in like canister, like grenades, and the enemy just throw it into your trenches during World War One, and then these canister pops up. They becomes like, you know, a greenish gases. That is Cl2 gas, and if the soldier inhale it, they will have like it burns, and they die a very painful death. But luckily, they ask like gas mask.
Yes.
Gas masks that cover both the eyes and the nose. So
Yeah.
by the end of the war, these kind of weapons are much less effective, and less people die because of them, thanks to the gas mask. Anyway,
Yeah.
let's go on crossbone.
Health hazard may cause or suspect of causing serious health effects.
They only suspect it, which means like you're not exactly sure. There's no real evidence for that.
Yeah. It's just like suspecting a crime.
Mm-hmm.
Some people.
It's not been proven yet.
This category include respiratory and skin sanitizer.
You know what you know what sensitizer mean?
Sanitizer.
Sensitive.
Sounds like
It makes
like
your
chemical.
skin. It makes your skin more sensitive, and there can be allergic reaction. It can cause allergy on your skins. Like it makes your skin more sensitive. It can also make your lung, respiratory, mean lung and throat, make your lung and throat more sensitive too, so you can cough, something like that.
Oh.
And it can cause your skin to be sensitive too, so you will have like rashes, red rashes everywhere, or something like that, allergy. You know what mutagen means?
It's like evolve with chemical. Evolution with chemical.
Muta means mutation. Gen means to make. It can cause mutation of the genes and can cause mutation. Carcino means like cancer. Cancer causing. It can cause cancer. Yeah, carcinogens.
And product that can cause
Reproductive toxicity. Reproductive means like in a sex organ.
generation.
In a sex organ, like for example, it can cause toxic in the sex organs of humans, so you cannot have children, for example, in the future. Organ toxicity means like it can poison each of your organs in the body, for example, like liver or kidney or something like that. Aspiration hazard. I think aspiration means like you inhale it, I think. Let me check. Aspiration. Aspiration. I think aspiration hazard means like inhale it and become a hazard, maybe.
Yes, like
they explain it. They explain it over here.
a respiratory sensitizer is a product that may cause allergy or asthma symptoms or breathing difficulty if inhaled. Skin sanitizer is a product that may cause an allergy skin reaction. Mutagen include products that may cause or are suspect of causing genetic defect, permanent change, mutation to body cell.
That can be passed on to future generations.
So it's like when you like evolve, it's like evolution. Like, something to do with evolution, right?
Mm-hmm. Basically, it mutates your genes. So basically, it can probably cause your children to be different from you because it can mutate your sperm and egg cells So when you make babies, your babies can be different from you in some way, or it can produce like, you know, what's it called? Defects, birth defects. Quite high, you know, like it can produce like babies that are weird or having any diseases from when they were born, you know.
Yeah.
Know what I mean?
Yeah, I understand.
Okay, yeah. So that's why they can say that can be passed on to future generation because of that. Your babies can have different kind of defects if you are exposed to that. So that's why I call mutagens.
Origin include products that may cause or are suspect of causing cancer. Reproductive toxic product may damage or are suspect of damaging fertility or the unborn child. It's like
Exclamation mark.
These products can cause health effects through oral, thermal, or
Or inhalation
inhalation.
pathways.
Can cause skin, eye, and respiratory
Irritations.
skin sanitizer, organ,
Toxicity and
toxicity.
Dizziness, like you feel like headache, like dizzy, you cannot really focus.
Like when,
But exclamation mark means like they are less toxic, you know, so it's just a hazard, but it's not that severe.
it's like a warning.
Warning, yeah, warning. Or damage the ozone layer.
Product with this simple may be hazardous due
Symbol,
to
symbol, symbol. Not simple, it's symbol.
symbol.
Symbol may be dangerous or hazardous to the ozone layer. Like for example, CFC, you know, gas, CFC gas, the one that you can find in sprayers. These sprayers. I mean, in the past, we use CFC gas to CFCs. Basically, we use fluorocarbon or CFC gas to help the sprays, you know, to spray out like continuously, so it won't get stuck, you know. So basically, the flow of the gas, it will go out like continuously. It will not get stuck because of the CFC gas. The problem is, CFC gas takes some time to get up to the atmosphere, like get up to the ozone layer, and then it destroys the ozone layer very, very, very seriously, very badly. So that's why I say hazardous to the ozone layer. Okay, let's continue. Exploding bomb. That's funny.
It's like a nuclear weapon.
No, not that bad. Not that bad. Okay, so explosion or reactivity hazard. You want to see how it is? I can send you a video. I can send you a video if you want to.
Sure.
Basically, things can react very, very badly if you do it the wrong way. So basically, let's say potassium in water reaction. Let's watch it, and you can see this video, for example.
Okay.
Moment. I'll send it to the chat, okay? Check the chat. Click on that link, please, can you?
It said you are leaving to click proceed to continue the link.
Just, okay, maybe it's better if I share screen then.
No, it's okay, it's okay. I just watch it.
I mean, just watch it now. I mean, it's okay. I mean, I can share. Let's say I can share. Yes. Now, okay, I can share now. Share sound. stereo. And then we can see how it is. You see it now?
I think I have to shut off my share the screen.
No. I mean, because only one person can share at one time, so that's why. Can you see it now?
Yeah. See it.
All right, good. Let's watch it.
If we continue down the column to potassium, we see that the potassium metal is also stored under mineral oil to minimize its reaction with the oxygen in the air. If we remove a piece of potassium metal,
basically potassium is very reactive with the air too, so that's why we have to keep them in oil, so they won't react.
We can see that potassium is coated over with a gray coating of the oxide. As we continue down the column, group 1 metals get softer and softer. The potassium cuts very easily. As we cut through the metal, we expose the shiny metal surface underneath.
Wow, it's very shiny.
Potassium is extremely soft. We can easily flatten out the potassium metal.
See, we can flatten
It has
it
a
out.
consistency of cream cheese. The potassium is a metal and is an excellent conductor of electricity. If we add a piece of potassium metal to water, we see that it reacts much more rapidly with the water than sodium. As you go down the column, the ionization energy decreases and the metal reactivity increases.
You see it explode.
The reaction is very exothermic, and the hydrogen that's produced ignites. We can test for the formation of potassium hydroxide by adding phenolphthalein. The solution turns red-purple due to the formation of potassium hydroxide.
This person didn't even wear gloves, which is bad, He shouldn't do that. Anyway, this is the way they represent the reaction. Potassium K with water, it becomes this one, and gas, this one. But we will learn it. Okay, now I think I can stop the share so you can share your screen now. You can share now. Oh, it say Anne has started screen sharing.
Can you see it?
No, I haven't. Maybe it's lagging a bit. Oh,
Yeah,
moment. Okay, let's learn all the way into like 1220 then. Okay, I see it now. Exploding bomb or explosion or reactivity hazard. That's what I was talking about,
Yeah.
Can be dangerous.
Very dangerous. And this one is like toxic. Biohazard.
Biohazardous or infectious materials. Biohazard, so basically it means that it is not chemical, it is just the creatures like bugs and scorpions and snakes or something like that.
Yeah.
Can cause diseases in people or animals.
Or organisms or toxin that can cause disease in people or animals. These materials are microorganisms,
nucleic acids or proteins.
nucleic acid or protein that cause or is a probably cause of infection with or without toxicity in human or animal. Last one. Environment may cause damage to the aquatic environment.
You see the dead fish, right? There's a picture of dead fish and like a tree that has dead, that tree is dead.
Yeah.
So environment hazard.
These products pose either acute or chronic hazard.
Okay, acute means short term. Chronic means long term. So basically, acute means short term, and chronic is of course an adjective that means long term damage. Aquatic system means like inside, like aqua means water, So basically, aquatic systems, including like oceans, seas, I mean ponds, you know, like and lakes, rivers. You know, these are all water systems that okay, there are fish and other creatures in there, so they can damage aquatic system, damage trees, lakes, oceans, rivers, ponds, etc.
Yeah. It's like a matching game.
Oh, pictogram.
Pictogram. Product with this symbol may be corrosive to metal as well as dry.
No, it's not. Be careful.
Not.
Just read carefully first, okay? Read carefully, and then you can match.
Yeah. And a product with this symbol may correspond to metal as well as in your eye. It's used
No, oxidizing hazard is the one on top, around, yeah, like a fire with a circle.
Yeah.
That one is biohazard, isn't it?
Nope.
No. Careful.
Yeah. May cause less serious effect or damage to the ozone layer.
Good.
It's used to represent explosion or
Exactly.
reactivity hazard. Usual.
Good. That one is like may suspect, but the one with the skull is like, it's very dangerous. It is known already. You don't have to prove it anymore. Cause death or toxicity. Okay. Alright. Good. You know it now. Okay, product label. Product K1. Okay, this is like French and English. Produit Can you read French? Can you read French?
I think a bit. Motel and
Indigestion. Indigestion.
Instruction.
Provoque en irritation cutanée, I think.
Yeah.
I'm not so sure because the last time I learned French was like, I think 28 years ago.
Oof.
It's like when I was in kindergarten. And then since then,
Peut-être de protection.
gants, găng tay. Okay, gants is like gloves.
C'est l'avènement.
Synonyment. What? Okay, manipulation. Manipulation, yeah.
This is
weird. I mean, French is weird. I know.
Wash hands thoroughly after handling. Do not eat, drink, or smoke when using this product. Store locked up. This piece of container in accordance with local regulation. If on skin, wash with plenty of water. If skin
Irritation
irritation,
occur. Shall we take a break first now?
yeah.
I think we should take a break first. It's been a lot. Okay. All right. Let's get back now. Product K1.
All malfunction, stupid, and importer of a chemical product sold to Canadian consumer must assess the risk of each product they sell, then display hazard symbol, warning statement, instruction, and first aid treatment must be on their product container. Label must be in English and French. They may be bilingual as one label or be represented as two labels, one each in English and French. Part of a product label. A pictogram is a graphic representation of the hazard posed by the product.
Mhm.
And a single word alert due to the product degree or level of hazard only to signal word use, danger or warning. A danger hazard is more observed than one marked warning. Hazard statement. A short, standardized sentence that provides information about the exact hazard of the product. For example, fatal if swallowed.
Mhm.
A product that may cause is more hazardous
Right,
than
and one
one.
suspected of causing. Because they only suspected of causing something, it's not proven true. And may cause actually is more hazardous. It's like a different level, you know. So the lowest is suspected of causing, and then level 2 is like may cause. Level 3 is when they have proven it already. So it's like danger. So there are different levels of hazard.
Yeah. A product is the common brand chemical name of the product identifier. First precautionary statement tells you how to minimize and or prevent hazard associated with the product. Instruction about storage, handling, first aid, personal protection, and emergency. Protocol may be outlined. For example, wear eye protection.
Like like goggles, you know, goggles, you know.
Yeah, goggles.
Goggles, sorry, goggles. Not googles. Goggles.
You said Google. That's kind of weird.
Why did they come up with the name googles? Like
I like
goggles, okay. Maybe see through the glass of something. It's weird.
So there's like pins. This part is shown and contains sentences that provide information about the exact hazard of the product.
Mm-hmm. Liquid finger, pro-strength clog destroyer. This one is the one that we use to unclog the kitchen sink and maybe to unclog the toilet, you know.
Yeah, like clean it.
But this one are very corrosive, because it contains sodium hydroxide, a strong base in high concentration. Do not use with plunger or in toilets. They do not use in toilet, really? Because it burn dangerous fumes when mixed with other products.
Next, it is the common brand chemical name of the product.
Pro strength liquid film clog destroyer. Corrosive. Corrosive.
A signal word that alerts you to product degree or level of hazard. Danger. It is graphical representation of the hazard posed by the product. So it's like Sport tell you how to minimize and or prevent hazard associated with the product. So I think that's it. And let me answer for question and something. Laboratory safety. You also have to understand some lab need in order to use equipment correctly and avoid injury. Reviewing the learning goals and success criteria to learning activity. And yeah, I think that's it to the periodic
table. Is that all?
Yeah.
Okay. Response to maybe okay, so tomorrow let's do, what do you have for math?
Math?
I think you're pretty far already in math, so maybe just this week do more science, I think.
Yeah, more science.
Okay. Okay then. Okay, let's just let me just copy this thing, chat to you, and then we can end the video here. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh cái đăng ký kênh đó, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.